Okay, assalamualaikum and good day. So today I'm going to show you how to prove the basic identities. You don't need to memorize, but you have to understand of how to get these three basic identities formula. Okay, so let's start. So basically in trigonometric we know that we have to use the Pythagoras theorem to help us, okay, to help us in solving questions involving trigonometric. Okay, so what we do, we must have a right angle triangle, because in trigonometry we must have this. And then we see that we have theta here, and then using the Pythagoras theorem we know that if this is A and this is B and this is C, so to get C squared is equals to A squared plus B squared, right? So from this formula of Pythagoras theorem, we are going to get the three basic identities of trigonometry. Now let's start. Okay, now the first thing first is if we do the sine theta, if we want to find the sine theta using the Pythagoras theorem, so we have, remember that so cha toa, the formula to find sine, cos and tangent. Sine theta is equals to A over C, cos theta is equals to B over C, and tangent theta is equals to A over B. Now we probably need to find we are going to use the second cot and cotangent as well. So I'm going to do this as well. Cosecant, you start with cosecant first. Cosecant is 1 over sine theta. So if it's 1 over sine theta, so it's supposed to be C over A. And then we have secant theta. Secant theta is equals to 1 over cos theta. So this will be from cos, should be C over B. And cotangent theta is equals to 1 over tangent theta, which brings us to B over A. Now let's look at these formula from the Pythagoras theorem. So basically we are going to divide this with 3 sections. So 1, 2 and 3. So why I divide it with 3 sections is that I'm going to divide the formula with all these C, A and B. Okay, why? Because we want to find the 3 basic identities. Okay, so if I divide this C squared equals to A squared plus B squared with C squared, so I'm going to divide it with C squared, yeah. So what happened is that C squared over C squared is 1. A squared over C squared is actually A over C squared plus B over C squared, right? Okay, now 1. A over C squared is actually sine theta, right? Because it has squared. So I'm going to put sine squared theta plus B over C squared is actually cos theta. So I'll get cos squared theta. Right, so that is our first identities. Okay, right. What if I divide it with A squared? So C squared equals to A squared plus B squared. I divide it with A squared. So everything has been divided with A squared. So we'll get C over A squared equals to 1 plus B over A squared. Alright. So let's look at the Pythagoras theorem that we did at first, right? C over A is actually, yes, this one. So secant theta is actually C over A, right? So C over A is cosecant squared theta equals to 1 plus B over A is actually cotangent theta, so B over A, right? So I'm going to replace that is cotangent squared theta. Now that is our second identities. And last but not least, using the same Pythagoras theorem formula, a square plus b square. I divide it with b squared. So what happened is we have c over b squared equals to a over b squared plus 1, right? So let's say c over b squared is c over b. C over b is, yes, that's it. It's secant squared theta. So secant squared theta equals to a over b is tangent theta. Tangent squared theta plus 1. Right? So that's it. We have 3 basic identities that you need to understand. And if you want to memorize this, it's up to you. Right? Okay, so I've taken out the identities, the 3 basic identities, and I put it here. So we are going to use this to solve self exercise 6.6. Okay? So here you go. So I've copied the selection, this one just now, and put it here so that we can use this as our guidance to self exercise 6.6. okay, so let's start. So question number 1, it says that alright, this one. Okay, question number 1 said that without using a calculator, find the value of each of the following. Okay, right. So question A, cos square 80 plus sine square 80. We know that the angle is the same. So according to the first identities, we know that they have the same angle. So we say that it's supposed to be 1. So cos squared 80 plus sine square 80 is equals to 1. Now for question B, secant square 173, you see, they have the same degree. So using the same degree, using the same one, let's look at question number 3. Let's look at the basic identities for 3. Let's rearrange it. So it happens to be secant square theta minus tangent square theta is equal to 1. So is it the same? So both are showing the same, right? Theta and theta, and this one is 173 and this one is 173 as well. So it's supposed to be 1. Okay, easy, right? So the second one is 1 minus cos square 45. 1 minus cos square 45. Cos 1 minus cos 45. We know that it's using the first identities. 1. So if I take it out, sine square theta plus cos square theta is equal to 1. So sine square theta is equal to 1 minus cos square theta, the same, right? With this one, so it happens to be sine square theta. Sine square 45. So because the question said that without using a calculator, then we know that sine square 45 degree. We have learned this in special angle, where special angle said that if it's 45 degree, so this is 45 degrees, so this is 1, this is 1, this is square root 2. So using this, sine is so is 1 over square root 2. So square root it, and you'll get 1 over 2. Okay, so question D, the last one is cosecant squared 8 over 5 pi. So they are using the red pi, 8 over 5 pi. So I think this is using the second identities. So if I rearrange it, 1 plus cot squared theta equals to cosecant squared theta. So 1 equal to cosecant squared theta minus cot squared theta. So this is the same one, right? You see the same angle here. This is also the same angle. So it's supposed to be 1. Alright, easy, right? Okay, so the second question. So given cos theta equals to m, determine the values of the following in terms of m. So because the question gives us cos theta equals to m, so we have to understand that cos theta is using the same right angle triangle. So you have to draw your own right angle triangle. because I mentioned earlier, to solve trigonometry, you must have the right angle triangle. So we say that this is theta, so cos is cha. Cha is adjacent over hypotenuse, meaning that m is actually cha m over, because it's only m, so it's supposed to be m over 1. So 1 is here, because 1 cha is adjacent, so this is the adjacent over hypotenuse, and this is the hypotenuse. So can you get the opposite side? So using the Pythagoras theorem, to get the opposite side is 1 minus m squared square root, right? As easy as that. Okay, now let's continue to solve question number 2, because we have all the sides, so we can solve this question. So that's why in this kind of question of trigonometric function, you must draw the right angle triangle. If not, it will not help you to solve these kind of questions. Okay, so secant squared theta, meaning that we have 1 over cos squared theta. Now, because we have cos theta here, so I say that this is 1 over m, because this is squared, so we have to put m squared, right? So that is the answer for secant squared theta. In terms of m, right? So it's in terms of m. So B, sine squared theta is equals to, sine is so is opposite. So opposite is 1 minus m squared, because it's square, so I have to put square as well, over 1 hypotenuse, right? So the answer would be 1 minus m squared over 1, or you don't need to put 1, right? So question C, cot squared theta is equals to 1 over tangent squared theta. So this is 1 over, tangent is toa. Toa is opposite, so the opposite is 1 minus m squared square root over adjacent m squared. So this is squared and this is squared as well. So the answer should be m squared over 1 minus m squared. Right, that is question number 2. Okay, next question is question number 3. It is given that theta is in between 0 to pi over 2, and tangent theta is equal to 3. So the question said that you cannot use the right angle triangle, find the values of sine theta and cos theta. So what are we going to do here is, okay, so from the restriction here, the limitation is from the 0 theta to pi over 2. Pi over 2 meaning that it is between 180 divided by 2, it's between 90 degree actually, okay? So tangent theta is equals to 3, so we know that tangent theta is equal to sine theta over cos theta, which is equals to 3 over 1. Okay, so because the question said without using the right angle triangle, so we know that sine theta is equals to opposite over adjacent. So opposite over adjacent, so this is opposite over adjacent, opposite over hypotenuse. So cos theta is as well adjacent over hypotenuse. Okay, so because this is opposite, this is adjacent, so the hypotenuse is 3 square plus 1 square square root. So we got 10, right? So the opposite is 3 over square root 10, and cos is 1 over square root 10. That's it. Easy as that. Okay, that is for question number. Okay, last question for today, question number 4. So let's look at the diagram on the right. Right angle triangle ABC, write the following expression in P and or Q. So for the questions here A, B and C, you probably need to use only P or only Q or both. Okay, so because the question says that cos square is, so meaning that the angle is here. The angle is here. The name angle is here. So we have opposite. This is the opposite for P. We have the hypotenuse for Q, and we have to find the adjacent. Okay, so how to find the adjacent one? So using for question A. For question B, cosecant square A minus 1 is equals to, now let's see cosecant squared A. So I think this is using the second one. So we have cot square theta is equals to cosecant square theta minus 1. So this is actually equals to cot square theta. Oh, so because the question use A, so we have to use A. So cot square A is actually 1 over tangent square A. Right, tangent is equals to 1 over TOA, opposite. So the opposite is P over square root of Q square minus P square. Right, so square, don't forget to put it square. So if we simplify this, it happens to be 1 over P square over Q squared minus P square, and we rearrange, you get Q square minus P square over P square. Right, okay. So the next question, question number C, the last question, yeah. So the last question, see that I'm going to paste it here again. Okay, so for question C, it's going to copy this and paste as well, because this will be our guidance. So if you can memorize, or if you have to put notes with you, then you don't need to panic. So question C, 1 minus secant squared A, I think we have to use the third identities, right? So it's tangent squared theta. Wait, so this is quite tricky. Alright, so this is 1, I take secant squared theta to the other side, and then it will happen to be 1 minus secant squared theta equals to negative tangent squared theta. Okay, beware of the positive and negative one. Okay, so meaning that question C, this is equal to negative tangent squared A. Right, okay, so we have negative 1, negative 1 tangent squared A is P over square root Q square minus P squared. Okay, square it. Okay, because only tangent squared that squared, so you don't need to put a negative to be squared. Okay, so we have P squared over Q squared minus P squared. That's it. Right?